Good afternoon, ladies and gentlemen. My name is Chris Devon. This is my partner, Daisy Lett. And today we'd like to present to you our project, Geobot. First, we'll talk about why we decided to make a robot geologist. Then we'll go over the various systems it uses and how they operate. And finally, we'll demonstrate some of Geobot's capabilities.
Geobot is specifically designed for field geologists to reduce risks from working in a dangerous environment. According to the Bureau of Labor and Statistics, the fatality rate of field scientists is 0.9%. That's 77 deaths a year. We wanted to reduce those numbers by creating a robot that allows geologists to do their field work without exposing them to the harm.
This is a well-done picture by my partner, Daisy. And although Geobot is a large, capable machine, our 35 amp-hour battery carries enough power to keep Geobot running for up to 16 hours. Go ahead. A video camera can be used for navigation, but we've also included 2D LiDAR mapping, which alerts the driver to obstacles from any direction. When interesting samples are found, the robotic arm is used to collect and store the objects in the onboard storage compartments. GPS tracking remembers the location of the samples and the route that Geobot takes.
Geobot is equipped with a laser imaging detection and ranging system that allows it to create a 2D map of its environment. The LiDAR is situated on top of the rover, 1 foot from the ground, and from the base of the LiDAR there is a 1 inch of non-detection range, and from there the detection range is up to 9 feet. The way that the LiDAR system works is that it shines light at an object, and it calculates this distance by taking the travel time times the speed of light divided by 2. The software then extracts this data and plots a 2D map. As an example, here's a 2D map generated from our electronics lab at our school. Geobot is also equipped with a global positioning system that continuously log location coordinates. And this file is it's stored inside the GPS module, and it can be extracted using Google Maps. And here's an example of a GPS track from my school to a nearby store.
Our robotic arm is very flexible and capable of collecting samples in a large area in front of Geobot. The arm uses hobby servos and has a modest lifting capacity of about 1 pound, but this is sufficient for medium and light density rocks. We chose 4 3x3x5 compartments because we felt this was a good compromise between the size and number of compartments. Once the operator has grabbed an object, with the arm, a single button activates the sample retrieval, which will place the object in the next empty compartment automatically.
Geobot also has 2 cameras, one at the top for maneuverability and one in front for the robotic arm. The camera at the top is capable of a 360-degree pan and a 180-degree tilt. Therefore, Geobot can see all around its environment as well as what's above it. The camera in the front is basically to help guide a geologist when they're trying to retrieve a sample using the robotic arm.
Although this controller is very affordable, it offers 6 channels of control, which allows us to operate all of Geobot's systems with just 2 controllers.
We started the project in July and we are almost done. All we have to do is do some minor software upgrades and complete the manual. This project required 1,882 hours. That's roughly 12 months for a full-time employee that works 40 hours a week. Actually, this is a very aggressive deadline considering all the complex modules that we had to research, build, test, and integrate. It at least required a team of 4, but my partner and I did it in the aggressive time frame, and we feel very accomplished.
Yes, we do. This is a conceptual diagram. Of the systems Geobot uses. An Arduino Mega processes data for the steering and robot arm systems, while the video, navigation, GPS, and drive systems operate independently.
So how does Geobot work? For the sake of brevity, I'm just going to briefly explain how the various signals travels through our hardware system. The PWM receiver receives the signals for the steering, the robotic arm, the camera, and the drive motor. The Arduino manages the signal for the steering and the robotic arm. while the camera and the drive motor is solely controlled by the joystick. The LiDAR, the GPS, and the video camera is independent of the entire system, and each having their own transmitter that transmits the signal to the base station. At the base station, you have the receivers for the LiDAR, the GPS, and the video, which then sends the information into the software, and then it displays this information in a graphic user interface on the laptop. At the base station, you also have the two joysticks, joystick 1 for the drive and the camera, and joystick 2 for the robotic arm. The beautiful thing about our robot is that the algorithms that we use are very simple, and it's consistent throughout all of our system. For example, all it does is it scans for a signal. When it receives it, it processes the signal, and it sends the output to the particular hardware. In conclusion, we learned a lot from this project. We learned to be avid online shoppers looking for the best deal. We learned to make use of our resources. We also became great problem solvers because getting it right the first time was very important. And we didn't have the luxury to make that many mistakes, given our time constraint. We also learned that there is more than one solution to a problem, and choosing the right one is imperative. I also learned that Daniel and I could probably use this at the AEE to pick up our lunch and coffee at Megabytes Cafe. Using the video feedback system, we can drive it to the Megabytes Cafe and pick up our coffee. There's 4 compartments for different orders and a platform to stack our lunch. With no further ado, we'd like to show you a video that demonstrates the capability of our rover.
Thank you very much.
Does anyone have any questions for these roboticists while we're here? We have a little bit of time now. Go ahead, right in the back.
Have you had any work, have you worked with First Robotics, Bot or Vexel?
I think I heard something, is it a robot competition? Is that what it
is?
is?
A robot competition.
I've always read about it and I've been very interested, but this is actually the first one of, I think probably this is, I don't know how many robots you've made, but this is one of our first robotic ventures.
Okay, I was just curious.
Thank you.
Actually, no, we did. We went to a contest in Berkeley. Does that? Oh yeah,
We entered this robot into the contest.
we did a contest in Berkeley.
We actually won second place in the IEEE design contest.
Yes.
Don't be shy. They're all yours for right now. Anyone else?
How does it fare on uneven terrain?
Not well. We had to redesign the steering system, and that cost a little bit of money with the linear actuator and getting the geometry right. And so after that, after it was mobile and moving, we decided to focus on the electrical portions of the things to
Yes.
better focus with our senior project. We did have many ideas of suspension with springs in the front and back, but then we'd have to make the mobile, the front and the middle motors on some kind of rail to move up and down as well. So we did have some ideas for suspension, but ultimately they proved a bit expensive.
We were also thinking about putting bigger wheels on the rover, but then they were too expensive given our budget constraints, so
Yeah,
we
we
just
did
settled
think-
for.
Inflatable wheels might give it some improved off-road performance without any modification to the frame.
Yes.
So, what was your main challenge for this rover?
I would say each little system had its own challenges.
I guess every module had its challenge, parts that didn't work. The programming was intensely stressful.
Lots of trial and error in there. I don't think there was a single thing we put on that didn't have some kind of tweaking
Yeah.
that went to perfection.
I would say the programming was the most challenging aspect. The hardware was easy because at least you could see if something is wrong, you can test it. The programming, you have to go line by line by line on a 100-line code, trying to figure out which logic is flawed.
So now it's finished. If you were doing this again, what would you do differently?
I think what we would do is maybe add some more joints to the arm or give the arm a bit longer reach. Because
Yes.
the way it is, it can pick up everything in the area in front of the Geobot, but you do have to drive up to the rock to pick things up. But we do have a secondary camera to aid in that navigation. So it's doable, but a more dexterous arm might allow easier operation.
I would also like to include a lot of upgrades, like an FPV video goggles, so you can actually put these on and you navigate the rover through the goggles, so it's like you're there. The other one is to install a GSM module so that you can operate the rover anywhere in the world using 4G, but you have to pay for the module, which is $300, and pay for the data, things like that. That's what I would like to change.
Did you guys have experience with Arduinos before, or what made you choose the Arduino platform instead of something like a Raspberry Pi or whatever?
We chose Arduino because there was a lot of resources online that we could use. It's a very large community, so when we needed help, we could just go online, do some research, and there's a lot of people that have done similar things. And we basically took a bunch of ideas together, tweaked them to however we wanted it. We didn't use the Raspberry Pi because it was new in the market. There wasn't as much resources, so to be safe, because given our time constraint, we had to use what was most available and what had the best access to resources. Do you?
You had many constraints on this project, time being one of them. How did you manage the project itself?
Well, time and finances actually, because oftentimes the fastest solution is also the most expensive. So we had to try and make some kind of compromises in our designs. I think it's the robot arm, we got the bracket and the servos was kind of a pre-made product by a company. We assembled and put everything together, but for example, the gripper, we didn't print out each little part, we bought that as a unit. We tried to save time when we could, and it came close, but we finished in time.
And from a project management standpoint, we actually built the rover modularly. So we built the robotic arm once, we built the steering system, we built them in a way that was, we built them individually and made sure they worked. And then we calculated how much time each one was going to take. And from there, we noticed, like, oh my God, we need more people to do this job. So we had to sacrifice a lot of our Saturdays coming in to make up to complete all the work.
Next.
Yes, they do.
What's next?
What's next? Well, if I go for my master's, I would like to continually upgrade this robot to something that I always wanted to be like something that could be used in STEM to help little kids learn about technology, science, engineering. Like the GSM module, when I start working, that's the first thing I should probably buy one for it and install it. So that maybe kids in classrooms could operate the rover while they're in Palo Alto and the rover's here, they can operate it.
Yeah, I think I'll have to come back and take a look on it because you're going to be volunteering. You get to spend all this time with me. I'm going to have to come back and take a look at it too.
Exactly.
When are they available for wholesale? Just kidding. No, seriously, there was a question about what would you do differently? I'm curious, what do you feel like are the most successful things about this particular robot, this rover?
I'm very happy with the automation with the arm. Once it's grabbed something, before we had the automation, we'd have to try and aim and get the rock into the compartment ourselves, which is very difficult. So it's very much a user-friendly improvement, the automation.
I think the most, my favorite is the LiDAR. I mean, that was a very complicated program, and it was something that we had to learn ourselves within the time constraint. And I think that was probably our biggest accomplishment, was learning that program and having it work.
What was the time constraint for those of us who don't know how long you were working here? I'm over here.
Well, we only have our curriculum is an accelerated program. So we are a 2-year program instead of 4. So everything that we do is condensed to half the time. So at regular universities, they probably have more than a year to do their senior project. We only had about
8 months.
8 months to complete it. So.
And like we said, we were working for over a year, so we actually started the project before we entered the class to ensure that we have a chance of finishing it.
Yes. Yes, sir.
I was interested in how you chose your programming languages. You chose Python, and since one of your experience, why you chose it, and as you said, there's many.
I chose it once because it's open source. And there's a lot of resources out there for us, just like the Arduino. And Python is a higher level language. One line of Python is about 10 lines of C++. So it was a lot easier to program and easier to manage.
And one more, how far can you operate remotely with Python? How far is the range of your control?
Of our control system?
That's the worst question you could have got. As you noticed in the slides, our radio control receivers, all of our systems have advertised ranges of hundreds of feet, 500 feet. But we noticed that our limitation was about 100 feet realistically.
Yeah.
With more money, we get it for you.